Okay, Assalamualaikum and good day. Salam sejahtera. Okay, so today we will continue with integration topic. Okay, Bismillahirrahmanirrahim. Okay, so there will be some elementary integration and also definite and indefinite integrals. Okay. Okay, so before this, we have learned about differentiation, right? Okay, so if we want to differentiate, actually, we want to obtain the derivative, okay, which is df over dx. Okay, and then the reverse process, okay, is to obtain the function f of x, okay, from the derivative, okay. So this is called integration, okay. So basically, it's just like okay, y to dy dx. Okay, let's say this is called differentiation. Okay, and then from dy dx to y back again to its origin, we call it as integration. Okay, so usually we use integration, okay, to find the area between a curve and the x-axis. Okay. So next we go to elementary integration. Okay, so let's say, okay, given there is dy over dx equal to 2x. Okay, and then we have to find yx. Okay, so the differentiation of the function, okay, is yx equal to s squared plus c. Okay, so c is a constant. Okay, so from this function of y, okay, so we get the derivative equal to 2x. Okay, so therefore y equal to x squared plus c is a solution to the problem. Okay, and then we can say that, okay, c is known as a constant of integration. Okay, we say that 2x has been integrated. Okay, so which is we get y equal to s squared plus c. Okay, and then, okay, this is normal, I think common knowledge for everybody. This is the sign that denotes the integration. And then we have ds, okay, can be dt or whatever alphabet that is indicate the independent variable. Okay, so this is how we write it. Okay, let's say we are given dy over dx equal to 2x, right? Okay, so what we have to do is we just transfer dx to here, to x dx. Okay, and then we apply the sign of integration left and right hand side, so 2x dx. So this will cancel out with d. So what left is y equal to 2x dx. Okay. And then, okay, and then from the given here that this is from the integration, we will get y equal to x squared plus c. Okay, don't forget the constant of integration. Okay, and then, okay, let's see this example. Okay, given dy over dx given dy over dx, okay, dx equal to cos x minus x. Okay, so we have to find y. Okay, so what we have to do is, okay, we have to do some integration. So just transfer cos x minus x dx here. Okay, you can put some bracket and then we put some some the symbol of integration. So this one we cancel out. So what left is y equal to cos x minus x, okay, dx. Okay, so now we have to find, okay, what is function that we differentiate that we can get for each term here. Okay, so maybe we can see, okay, this one, okay, this one. Okay, so what is the function that we can differentiate in order to get the cos x? So let's do okay, so dx y, okay, y, so that we can get cos x. Okay, so it will be what? It will be sin x. Okay, so this is the answer that we want to find in the box. Okay, and then let's say for x, okay, what is the function? Why this one cannot become a box? Oh, okay, yeah. Oh, okay. New thing. Okay, so equal to x. So what is it? So it will be x squared, right? Okay, x squared. And there's supposed to be, there should be 2. Okay, there should be 2 in here. Okay. Okay, correct. So there should be some 2 here. Okay, so now there's no 2. Okay, what we have to do is we just have to cancel 2 with multiplying the whole side here with 2, and then this one also. Okay, is it correct this way? Oh, okay, sorry. Okay, so differentiate this, we should get 2x, right? Okay, so there's only x. Okay, so what we have to do is we have to multiply with 1 over 2 to cancel out the 2. Okay, to cancel out this one. So this one also we have to multiply with 1 over 2. So it will become d dx x squared over 2. So we okay, x squared over 2. So this one should be in bracket. Okay, equal to x. Okay, so now we have found the answer which is in the box. So just write back. So y equal to this one sin x. Okay, and then we have x here plus what is it? Oh, sorry, it is minus, right? Okay, minus x squared over 2, and don't forget plus c. Okay, so that's it. Okay, next. Okay, so we will look for this one. Okay, so Oh, forgot to read the question. Okay, so find differentiation, the derivative of what is it? This function, okay, and hence deduce that, okay, integration of Sn dx is equal to this one. Okay, so we want to find the differentiation, okay. So just, okay, find the differentiation of xn plus 1, and then n plus 1 plus c, okay. So this one is we are using the concept linearity here, okay. So linearity, which we can separately differentiate these two functions, okay. So d of, okay, d over dx Sn, think on it, xn plus 1 plus 1, okay, plus d dx c. So this one we will get 0. Oh, forgot again. Okay, so this one also we have to use concept linearity, okay. So linearity of two functions. Okay, this one is linearity of constant. Okay, so where is the constant? So this is the constant. So we just write n plus 1, okay, and then d over dx Sn plus 1, okay. So okay, so it will be we just write down the constant here. Okay, so the constant, the nx, oh, forgot, sorry. Yeah, this should be fraction, right? So it should be 1 n plus 1, okay. 1 n plus 1, okay, and then x, so n will be here. So okay, so we can cancel out this one. So what left is only Sn, okay. So as actually, so in order to get the, so this is how we get Sn through differentiation, and from this one we can get back to the original y through integration, okay. So that's why we're saying we are deducing that, okay. Therefore x integration of Sn dx, we will get 1 n plus 1 x n plus 1, okay, n plus c, okay. So this one next. Okay, so use, okay, so table 13.1, okay, show some several common functions and their integrals, okay. So this is how we get the formula, okay. So basically this is the formula for Sn that we get earlier, okay. That is how we get this formula, okay. Okay, then so okay, so for x4, so for this question, okay, for A question, x4, right? Okay, so we have to use this formula. okay, given in the table, and also we are already proven this one, okay. So Xn, so it will be x4, right? Okay, so n is 4, okay, n is 4, okay, n is 4. So x 4 plus 1 is 5, okay, and then 4 plus 1 also 5, so that's it. And then don't forget plus c, okay, x to the power of 4 is equal to this one, okay. Okay, so just use this table, okay, for simplicity, okay. Okay, and then don't forget about C. So you can see here everything got C at the end. Okay, only one C. Okay. Okay, so next, integration as a linear operator. Okay, so same with differentiation. If there are two functions, okay, f and g, let's say two functions. Okay, first maybe they are grouped together, so we can ungroup them, okay, and then do one by one integration, okay. So f first and then plus and then integration of g, okay, and then we have in terms of constant, okay. So for, let's say in this case, this is the constant, so we can uh, let it move out, okay. We can, let's say, put it out of the integration, put it beside, okay, put it outside or whatever. Okay, and then it can be also combination, okay, with constant and function. So what we have to do, okay, so this is what we are given, plus bg dx, right? Okay, so what we have to do is, okay, so we are given here, okay, so we are given af plus bg dx. Okay, so first we just separate the function first. Okay, function first. Okay, so af dx plus bg dx. Now constant. Okay, one by one. So a will be outside, f dx plus b will be outside, g dx. Okay, okay, so maybe we can do some, okay, some example here to show the integration and to show the linearity. Okay, so in this case, okay, let's say we do B. Okay, this is the question. We have to integrate, okay, 3t to the power of 4 minus square root t, okay, dt. So what we have to do is go for function first, separate the function first, 3t, 4 dt, and then minus t dt, okay. So we can put outside the constant, okay, and then for this one we just convert square root into 1/2, okay. So now we okay, based on the table, so this one will be t to the power of 5/5, and then write 3, okay, and then this one will be 3 1/2 plus 1, okay, and then this one also 1/2 plus 1, okay. Then don't forget minus at the end got to be c. So we get 3t to the power of 5/5, okay, minus 2/3 minus 2 over 3, t 3 over 2 plus c. Okay, please note that only a single constant of integration is required. Only one constant, okay? Okay. So next, we will look at integration of trigonometry. Okay, this one. Integration of trigonometric function. Okay. Some of the trigonometries, okay, identities, is not given directly in the table here, okay. So let's say for this one, we have cos squared t and then sin squared t, okay. There's nowhere we can find that sin squared t or cos squared t, right? Okay, so we have to use the trigonometric standard form. Trigonometric identities, okay. We have to use trigonometric identities. Is it? Okay, so let's say, okay, so this is cos squared t, okay. So, and then we just, since we cannot find the table, so we just simply, based on the trigonometric identities, okay, so this is that we can come out with, okay, the standard one. Okay, and then from here, we can find out what is the integration for cos 2t, which is maybe different color, okay, cos 2t. So where's cos 2t? Okay, so this one, cos, so it will be sin x, okay. So that's it. We just do some linearity, okay. We separate the 1 over 2 and, okay, so we will get this one t over 2 and this one sin 2t over 2, okay. This one is 1 over 2 sin 2t over 2, okay. So we get this one 4, okay. Okay. Okay, so and then, okay, so this is the cos squared t, right? Okay, so now we are using trigonometric identities. So sin squared t is equal to 1 minus cos squared t. So we just replace cos squared t, okay, that we get from above here, okay, into this one, okay, cos squared t. So this is what we get earlier, okay. So that's it. Okay, so and then just integrate this one. So this is for sin squared t, okay. Okay. Okay, then, okay, so let's do some example. No. Okay, so this one is just, okay, so let's say, this is, we have to find integration of sin 2t cos t, okay. So again, we have to use identities in table 3.1. So this is it. So it will become sin a plus b. So after that, we can easily, okay, so just replace a and b with a and b here, okay, which is we have 3 and 1. Oh, okay. We have a is 2, okay. A is 2, okay, and then b this one. Okay, so 2 plus 1, it will be 3. Okay, so we get 3. 2 minus 1 will be 1t. Okay, so plug in into this one. Okay, and then after that we can integrate it. Okay, because there will be sine 3t here and cos 3t here. Okay, just use the formula. Okay, so that's it. The tips that, let's say if you cannot find the trigonometric functions, just use the identity trigonometry. Okay, next we go for definite and indefinite integrals. Okay, so when it involves a constant of integration which is c, okay, this is what we call, or also known as, indefinite integrals. Okay, when we use the integration to find the area, so this is what we call definite integrals. Okay, so to estimate the area under function y of s, or the line, okay, the curve. Okay, so we just divided the curve into the area of the curve into rectangles. Okay, so each rectangles has width delta x. Okay, and then so let's say okay, maybe put, okay, so uh, okay, so this one. Okay, so in this case, okay, so rectangle 1, okay, figure 3, 13.16 here. Okay, so let's say rectangle 1 is y s2 delta s. Okay, we have y, okay, this is the y, and then we have delta s. Okay, we just denote it with s2. Okay, and then for rectangle 2, it will be y, okay, delta x s3. Okay, y, okay, let's say y at s3, okay, and then multiply with delta x here. Okay, so that is what you mean by, this is y at s3. Okay, it's too small, and this is what is it mean by y x2. Okay, this one. Okay, uh okay, and then loss. Okay, okay, so let area Sn, okay, denote the total area. Okay, so A in bracket Sn is the sum of rectangular areas. Okay, so this is the, okay, the y, the rectangle formula. Okay, which is y x I and then delta x. Okay, starting from I2 until the end. Okay, the end. Okay, okay, and then okay, so increase in area. Okay, we also call it delta A. So AX minus ASN. Okay, okay, so the formula will be just the same. YX delta X. Okay, YX yes, and then delta X. Okay, Okay, so delta A over delta X is equal to almost to YX. Okay. Okay, so and then when delta X is almost smaller, almost tend to go to 0, okay. So we just call this one as dO over dx, the differentiation, okay, equal to yx. Okay, so when we have the dA over dx, yx, okay, so just transfer dx to the dx, okay, and then we do some integration. This will be cancelled out, so what left is A equal to integration y x dx. Okay, so there should be some limits. Okay, what is the upper limit and what is the lower limits? Okay, so this will be the upper limit. Okay, the maximum number. This will be the lower limit. Okay. Okay, so in this case we have the upper limit is B. So it will be A squared. A area, okay, B, and then minus the lower limit, area A. Okay. So basically that is what we do if we want to find for some interval. Okay, so this is A. Okay, so this is A. Okay, the limit here is A. Okay. Okay, and then this is B. A, B. Okay, so the lower limit here, the limit here is B. So if we want to find between B and A, so what we have to do is B, okay, B, the upper limit, okay, upper always on the right, okay, the highest number, okay, minus A, okay, so then that's how we get only this area. Okay, so let's say the function is okay, so we can write the function, the integration into this point. Okay, after integrate we just put ax and then ba. Okay, so let's consider this one. Okay, 3 and 2. Okay, so we just write down again. So we just plug in the 3 first. Okay, we just plug in the 3 first into the x. So it's fine. And then minus, we replace x with 2 here. Okay, so this is 10 minus 5, we get 5. Okay, so this is how we write. So FB, the upper limit minus the lower limit. Okay, and then it can also be interchanged. Okay, let's say A to B. Okay, so we just write AA minus AB. Okay, actually it's the same if this one, okay, the previous one, but you have to put the negative. Okay, it's not being circle. Okay, so this fine. Okay, so it's just the matter of, let's say it is terbalik from this one, So we just add up negative here. Okay. The answer will be same. Just add negative. Okay. Okay, so let's do one example. Okay, so this one is given x squared plus 1, and then we have to find integration. The lower upper limit is 2, the lower limit is 1. So we have to integrate first, okay, to 1 x squared plus 1 dx, okay. So integrate, so it will become x to the power of 3 plus x, okay, and then there's no c here because it's area, so just put 2 and 1. So we replace x with 2 here. 2 to the power of 3 plus 2 and then 2, okay, minus 1 to the power of 3 plus 1, okay. Oh, sorry, there's no 2 here because we already put 2. Okay, so just put it short. It will be equal to 10 over 3. Okay. Okay, I think. Oh, okay. Maybe last one. Okay, the last one will be. Okay, this one. Okay. Okay, so find the area bounded by y equal to s to the power of 3 from x negative 3 to x negative 2. Okay, so you just write down x to the power of 3 dx, and then the maximum number is negative 2. This is negative 3. So integrate first, so it will be x4 over 4. Okay, and then we have negative 2, negative 3. So we just substitute negative 2 first, okay. And then minus negative 3 to the power of 4. So we will get negative 65 over 4. Okay, so that's it for this topic. Okay. Thank you and Assalamualaikum.